In this video, we'll learn how to make sources that are in the shape of a square wave, also known as pulses. We're going to make a voltage source that is a 1 kilohertz or 1000 hertz wave that is off when it's 0 volts and on when it's 3.3 volts. So let's go to LTSpice, create a new schematic, component, voltage, and we'll plop it down, hit escape, add our ground. Alright, so we have been right-clicking and giving a DC value for a DC source. If we want to create a pulse source, we'll go to Advanced and choose the pulse source. Now notice we have all of these different options. V initial stands for the off voltage, so whatever you want your lower voltage to be in your square wave. V on stands for the on voltage, which is whatever we want. So here in our picture we want 0 volts for the off voltage and 3.3 volts for the on voltage. We'll get back to T delay, T rise, and T fall in a moment. T on says how long do we want this on voltage to be on for? Well, we want it to be on for half of the period since we're creating a 50% duty cycle square wave. Duty cycle tells us the proportion of the time high over the time low in a single period. So in our case, we want it high for 50% of the time and low for 50% of the time in a period. So for a 1 kilohertz wave, the period is just 1 over that. So a period would be 1 millisecond. Half of that is half a millisecond, so I'll just put in 0.5 milliseconds. And as we know, the period has to be 1 millisecond. Number of cycles we can add if we want to know exactly how many of these pulses we want. If we leave it blank, it'll just be infinite. Okay, so T delay, T rise, T fall. These are telling us how long do we want to delay before we turn on. So if we want to start off at 0 volts and be at 0 volts for half a period, we could put that delay at half a period. So let's go ahead and do that. So 0.5 milliseconds. T rise tells us how long does it take to go from 0 volts to 3.3 volts. Well, we ideally want it to take no time at all, but since this is a real circuit, it has to take some amount of time to make that rise. So we can just put in a really small number. Now a really small number has to be relative to the period. So the period is 1 millisecond. 1 millisecond is a good amount of time, so let's just put in 1 nanosecond because relative to the period that's really small. So the fall time is how time does it take to go from high to low. So let's just again put in 1 nanosecond. So hopefully by clicking OK we will see a square wave produced that looks like this. So when we simulate and edit simulation command, now the time matters because we want to know how many periods we want to see. So let's say we want to see 5 periods. We know that's going to be 5 milliseconds. So I'll put in 5 milliseconds for how much time we want to run this for. And then let's run it. So let's see if we got the pulse wave we wanted. Okay, there it is. So notice we started at 0 volts. For half a period we stayed there as we indicated, and then it went high, 3.3 volts, and we have exactly 5 cycles of this waveform. Now let's say we were not paying attention to the time and we had chosen to simulate for a whole second, and we ran it. We looked at our output. It doesn't look like much because what we're seeing here is a whole lot of these pulses all going on for a long amount of time. So we can actually zoom in by clicking and dragging on a small section. Now you can see that, oh yeah, this is a pulse waveform. I just ran it for too long to be able to see it. So as I keep zooming in, oh, okay, there we go. I can see now my pulse waveform. Okay, so now you know how to create pulses in LTSpice.